In today's video, we are going to talk about conversion factors. In chemistry, even in all sciences and math courses, conversion factors are a convenient way to use ratios and proportions to convert from one unit to another. What we try to do is avoid setting up proportions the old-fashioned way and cross-multiplying and dividing. We try to do that all in one continuous calculation. And what we're going to learn today is not so much the chemistry conversion factors and the chemistry calculations, but get more into the habit of how to solve these problems. When we talk about conversion factors, we're simply talking about things like there are 60 seconds in 1 minute. There are 12 inches are equal to 1 foot. 4 quarters are equal to $1. We will also get into chemistry ones. For example, 1 mole equals 6.022 times 10 to the 23rd atoms, as well as others. Again, we're not learning about the specific chemistry conversions. We're just learning how to set these up correctly. So as a starting point, I'm going to ask you the question. You have 43 quarters. How many dollars do you have? Well, everybody's going to go right away 43 divided by 4 to get an answer. And that's correct. Mathematically, that's what you do, 43 divided by 4. And when you put that up in your calculator, everybody's going to get, oh, it's $10.75. Great, absolutely right. Now let me ask you this. Why did you divide by 4? So what I want you to do is take a second here. Think about why divide by 4? Because I'm going to ask you, why not multiply by 4? And many of you are going to sit there and say, well, it's just what you do. I just know I divide by 4. Well, then I'm going to ask, well, but you haven't proven it to me. Some of you then will start to say, well, there's 4 quarters in $1. Again, didn't tell me mathematically why divide. Then some will say, well, but quarters are smaller than dollars, therefore you divide, or $1 is bigger than a quarter, therefore you divide. And you try to elaborate into this whole description of what it is. Well, here's what we want to say is you just aren't describing the math. You know the math, but you need to be able to describe it. So here's what we have. We have 43 quarters, and we want to know how many dollars do we have. When we know there are 4 quarters for every $1. Proportion. Everybody knows how to do that. Well, then the math is cross multiply and divide. 43 times 1 equals 4 times x. Right. 43 quarters times 1 equals 4 times x. Divide by 4. Divide by 4. So 43 times 1 divided by 4 equals x, which is exactly right. Nothing wrong mathematically. Here's what we want to do is this is the math right there. 1 over 4. That is a conversion factor. So instead of going through and setting up an entire proportion here and then cross multiplying and dividing, collecting terms, and finally solving for x, all we're going to do is say 43 times 1/4, there's our answer. Now, again, yes, we are dividing by 4, but we want to get in that habit of when we get into more complicated calculations, being able to speed up the process by not setting up a formal proportion, not going through cross multiplication, not going through dividing and collecting terms and canceling, just jumping to write what we need. Give you another example. You have 297,000 seconds, and we want to know how many hours would that be. Well, right here are three conversion factors. Three values that tell us very specific measurements between two units. So what I want you to do is on paper, we're going to look at how we would set this up as a conversion factor, because all of you could say, oh wait, 297,000 seconds, divide by 60, that gives me minutes. Divide by 60 again, that gives me an hours. Or some of you might know, oh yeah, there's 3,600 seconds in 1 hour. Here's what we want to do. This is how we want to set up the conversion factor. We want to say 297,000 seconds, and I want to multiply by a fraction that goes from seconds to the next unit I want. And I'm going to do it the longer way. Well, the relationship is 60 seconds in 1 minute. And what I'm going to do is I'm going to multiply in such a way that I go from seconds to minutes. And that's simply saying, well, in 1 minute, I have 60 seconds. Now, why did I put 60 seconds on the bottom? Because you said so. Divide by 60. Here's the math why. Seconds are in the numerator, seconds in the denominator, they cancel out. Next step, I want to go from minutes to hours. Now, everybody knows I divide by 60. Why? Well, we're trying to leave, so to speak, the minutes unit and go to hours. So what's our next conversion? 60 minutes are equal to 1 hour. So in 1 hour, we have 60 minutes. And again, if we notice here, just like we would in math class and algebra, numerator, denominator cancel out. So what is the math? The math is simply 297,000 seconds divided by 60, divided by 60 again. And now we have our final answer. And if you punch it up in your calculator, it is 82.5 hours. Now, you might be thinking, yes, I could have done that in 5 seconds. Punch in the number, divide by 60, done. You're absolutely correct. But what we're trying to do is set up a process, a habit for solving more difficult ones involving chemistry concepts down the road. So, kind of short here, a little reminder. What are we really trying to do here? Number one, we want to start our calculation with what we're given, the measurement. 43 quarters, 47 quarters, 297,000 seconds. We want to multiply by ratios or conversion factors or fractions, however we want to call those, because that's really what they are. So we're going to want to multiply these by what's known, 60 seconds in a minute, 4 quarters in a dollar. Then we want to be able to reduce and cancel units just like we do numbers. And then finally, solve for our answer. If we can get into the habit of doing that, then great, that's what we want to do. So, what I have here is sort of a little skeleton box set up. Here's how every calculation would be. You're going to start by writing down the measurement or the number that's given, and then you're going to multiply by the conversion factor or several conversion factors. You may have to do it a second time, depending on how many things you need to convert. So that it ultimately gives you the answer you're trying to find, or the answer you're trying to solve for. As we do more of these, you'll be able to see kind of the big picture and truly make a multiple step calculation in one long continuous calculation. Last I'll have you just do here on your own, and you can pause this and come back and I'll have set up what the calculation should look like. But 17 days. You have 17 days. How many seconds is that? So I want you to set up a conversion factor, show your ratios, your proportions, and solve for the final answer. Okay, so here's the setup you should have. 17 days, and we actually multiply by 3 different conversion factors. One is 24 hours are equivalent to 1 day, 60 minutes in 1 hour, 60 seconds in 1 minute. And by setting it up this way, and again, most of you knew to multiply, but here's what we do by setting it up this way. We can cancel out units. Days and days are in numerator denominator. They cancel out. Hours and hours, they cancel. Minutes and minutes, they cancel. So when we do the calculation, first of all, to get the numeric value, our answer is 1,468,800 is our value. And our units are whatever unit that has not been canceled out. Seconds. So there is our final answer given that problem. Again, do we have to do it for days and minutes and seconds? No, but we're getting into the correct habit for it. 2 other things I just want to briefly mention, kind of ties in with conversion factors, volume, metric system. So briefly mention it here. If we have a cube, and the cube is 1 centimeter on every side, well, if a cube has 1 centimeter on every side, then 1 milliliter of liquid will fit into that space. Again, we're not talking about any weird temperatures or pressures or weird chemicals, just a standard conversion. So what we now have is a relationship between liters and meters. So by definition, this is another important conversion factor to remember. You will have to remember this. 1 milliliter is the same as 1 centimeter cubed, which is the same as 1 cc. Now, if we have something that is 1 meter on a side, that's really 100 centimeters on each side. Okay. Well, what we have here is a situation we have to take into account the volume of this. Well, 1 meter times 1 meter times 1 meter is equal to 1 meter cubed. But we have 100 centimeters times 100 centimeters times 100 centimeters equals a different value. If we look here, we have 100 centimeters times 100 times 100. And what we end up getting is 1 million centimeters cubed. Now I think, wait a second, I thought meters to centimeters, I learned back in the beginning of the section, meters and centimeters was just 2 decimal places. You're correct. But now look at the calculation. What did we just do? We did a calculation that involved meters and centimeters once, meters and centimeters twice, meters and centimeters 3 times. So because it's cubed, we really moved 2 decimal points 3 times. So it's truly 6 decimal points that are involved in a calculation like this. I will just leave this screen up here, again, just as a reminder.